Day 231 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. This time we're at day 231 and we're still going strong, y'all. Today we have question number 117, populating next right pointers in each node 2. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand as possible because we're all here on different levels of our programming journey, so we want a solution that everybody can understand. So let's see what the question says. It says, given a binary tree, populate each next pointer to point to its next right node. If there is no next right node, the pointer should be set to null. Initially, all next pointers will be set to null. So let's look at example 1 so we can break that down. In example 1, we have the input root equals a binary tree 1, 2, 3, 4, 5, null, and 7, which we have a picture of over here. Then the output is 1, the pointer to null, then 2, 3, pointer to null, 4, 5, 6, 7, right? So what these hashtags right here represent are the null, right? The pointer's the null. So this 1 points to null, that's why it's a hash right there, boom. Then we have 2 points to 3, then 3 points to null, right? 2 points to 3, then 3 points to null, so that's why we put the hash right there. Then we have 4, 5, and 7, 4 points to 5, 5 points to 7, and then we put the hash right here after 7 because 7 points to null. So let's look at the explanation, see what the explanation says. It says, given the above binary tree, figure A, your function should populate each next pointer to point to its next right node, just like in figure B. The serialized output is in level order as connected by the next pointers with the hash signifying the end of each level. So let's look at example 2 just in case they try to throw a trick question our way where root is a blank array. But if it's a blank array, the output will be a blank array because that means there are no values, there are no tree nodes, there are no nodes. So we're just going to keep it blank, and that's why the output is blank as well. So now that we understand the question, let's get into the solution. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check that link out in the description. And then after you do that, go ahead and like, comment, and subscribe, y'all. Your support is appreciated. Now, with all that being said, y'all, let's get into the question. Not the question, the solution. So the first thing we are going to do is we are going to declare a variable called next, and we're going to set that equal to root. And what that is going to do is it's going to keep track of the leftmost node at the current level and start with the root node. So after we do that, we are going to traverse each level of the tree starting from the root. In order to do that, we are going to say while let current equals next, because remember we just said next to the root. Then what we're going to do, we're going to open up the brackets. Now we're going to create a variable called child, and that's going to be a node. And then we're going to say var prev_child colon node question mark, and prev_child will connect the next pointers between the child nodes. Now we're going to declare another variable by saying var leftmost child, that's going to colon, that's going to be a node as well, question mark, and that's going to keep track of the leftmost node in the next level as we move down the tree. Then we're going to declare another variable, so we're going to say var node colon, which is going to be a node, so node, capital N node, question mark, we're going to set that equal to current. And this is going to iterate through the nodes at the current level. So boom, sorry y'all, should be 2 R's. Then we're going to come down here and we're going to traverse all nodes in the current level. And in order to do that, we're going to say while let temp equals node. We're going to open up the brackets. Then we're going to say let children equal square brackets temp dot left comma temp dot right, come outside the square brackets dot compact map, open up the brackets $0. What that's going to do is going to collect the left and right children of the current node if they exist. Then we're going to come down here, and now we need to connect the child nodes using the pre-child pointer. In order to do that, we're going to use a for loop. So we're going to say for child in children, open up the brackets. We are going to say pre-child question mark dot next equals child. So if the pre-child exists, we're going to set it to the next pointer to the current child. Then we're going to come down here and we're going to update pre-child to the current child by saying pre-child equals child. Then if the leftmost is not set, we're going to assign it to the first child found. And in order to do that, we're just going to say leftmost child equals leftmost child. Question mark, child. Then we're going to come underneath that for loop and we are going to say node equals temp dot next. And that's going to move to the next node in the current level using the next pointer. Then we're going to come underneath that and we are going to move to the next level by setting next to the leftmost child in the current level. And so to do that, we're just going to say next equals leftmost child, just like that. Then we're just going to come down here and we are going to return the root node after connecting all of the next pointers. And in order to do that, all we have to do is say return root. Just like that, y'all. That should be all she wrote. Let's run it. Make sure it runs how it's supposed to. Ooh, we got some typos. So let's see where the typo's at. So it should be a D right here. Then can I find leftmost child and scope? Where is that? Line 34. Leftmost child. So I guess. Oh. So this should be a capital M, y'all. Sorry about that. That comes from up here where we wrote it up here. This should be a capital M as well. Now let's run and see if that runs. Let's see how that runs. And look at that, y'all. It's accepted. So let's submit it. Make sure it stays accepted. Let's see. Oh, yeah, look at that, y'all. 36 milliseconds beats 24.51% of users with Swift, y'all. Not too bad at all. We're not going to worry about those numbers right now. We just worrying about getting the problem solved and understanding the solution after we solve it. We want to be able to look at a question and have the knowledge to solve that question. And then once we get good at answering these questions, then we'll start focusing on the time complexity and getting better with that as we move along further down our LeetCode journey. But right now, we just want to be able to get the question solved. I feel like this is a good solution for everybody, no matter what level you are on. So that's why we did it like this. I hope y'all learned something today. Oh yeah, before we leave though, did one more look at the code. Read it, learn it, love it. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.